Hi, so today we're going to be doing the ratio test. To do the ratio test for convergence, it's usually used on summations that look different than we've seen before. Like it's not just 3 to, let me see if I can write something here, to the, or 3 halves to the nth power, which wouldn't converge, it would diverge, or something like 2/3 to the nth power. It may be something like 2 to the nth power over like 3 factorial. Especially when you start to see factorials, there isn't a way to kind of simplify this or use other tests, so you're going to have to go along with the ratio test. Okay. All right, so prior to this part of our lesson, you should have copied this down, but we're going to adjust this a little bit. It is stronger if we use the limit of the absolute value of this ratio, that's why it's called a ratio test, of a sub n plus 1 divided by a sub n as n approaches infinity. If it equals a number, okay, it could actually equal infinity, by the way. If it does, then L would be greater than 1. Okay, in those scenarios, then we know that our series diverges. If it's less than 1, it converges. Yay. And then if it does happen to equal 1, then this is inconclusive. You're going to have to do another test. Okay, so let's see some examples and let's do them, and you'll get the idea of how to use the ratio test. By the way, this is our 7th test. Sometimes you may be looking in books where they also say the ratio and root test. The root test is not in our course. If there's time, maybe after the AP exam we can go over. We can definitely do something like that. Let me know. I'll come back and make sure that I do a lesson on the root test. So maybe that would be like an 8th test, or down the road it would be, the 10th test. It's something that you can use for your AP exam, but it's probably not going to come up because it's not part of the curriculum. So just giving you that heads up. Okay, so here we have 2 examples. Please make sure you got it into your notes. The directions are pretty much the same. Determine whether each series is convergent or divergent, or if the series converges or diverges. It can be stated either way. All right, so A is the summation of 3 to the nth power over n factorial. We'll talk a little bit about factorials. Please make sure that you prepare yourself in understanding factorials, especially if it's not just like 3 factorial, if let's say it's n factorial. And we're finding the sum from the first term to the infinite term, so it's an infinite series. And in B, okay, we have another infinite series. This time it's defined by a sub n is -1 to the nth power times n to the 3rd power over 5 to the nth power. So as you can see, there's no factorial here, but it's not something that we can maybe simplify and do a different test. It seems a little bit more, I want to say, confusing. Now, there's actually a test that's coming up that deals with this part here. This means it's an alternating series. So a little heads up on future lesson there. But we can apply the ratio test for it here, so don't worry about that yet. So let's go and do part A. All right, so for part A, what we first want to do is find not a sub n, that would be a sub n here, but a sub n plus 1. This must be an n and a plus 1. There we go. A little bit better. That would be 3 to the power of n plus 1 over the quantity of n plus 1 factorial. Okay, that's important to actually do its limit. Okay, because you need this as the numerator for your ratio. Okay, so this new equation goes into the numerator. Okay, make sure that you had at least this problem copy before you carry along. And the original one, or this one, it goes into the denominator, the nth term expression. Okay, so we're taking the limit as n approaches infinity. So now, if we look at what's inside the absolute value, okay, we have a complex fraction, so we're going to want to simplify that. And we no longer need the absolute value sign. It is important in later lessons why it is there. But if you look at it and you start plugging in values for 1, 2, 3, and very large values like 1,000 or 10,000, you'll see that you get a positive answer anyway. That's why we no longer need it. Okay, so I'm just trying to write this out, which hopefully you are very much trying to do as well in your notebooks. Okay. Now, you know that multiplication is commutative, and you are going to be able to simplify this expression here because same base, you can subtract the exponents, you get 3, or 3 to the first. Now, the factorials, you should have some practice with it, and like I said, especially with the n values. So think of a factorial. Okay, you start multiplying by 1, 2, 3, if only we knew what n was. Okay, and that factorial is something like this. Well, if you have the n plus 1th term, you have this times n plus 1. And because it's a factorial, which is a sequence here, these can all cancel except for that quantity of n plus 1. So this will cancel entirely, and just the n plus 1 would remain in the denominator. Now, if you look at this, we could definitely take its limit. Little practice there. We know that it's going to equal 0. So if it equals 0, as this does, then we end up knowing, since 0 is less than 1, that this series converges. Okay, just trying to write the rest of the series out. 0 is less than 1, so we're able to make this conclusion. And that's it for part A, so let's take a look at part B. Okay, so hopefully you got the idea of what steps to do in part A, because that'll help for part B. Okay, so here we go. In B, this is equal to a sub n. Okay, so a sub n plus 1 would equal a negative 1 to the quantity of n plus 1 times, okay, n plus 1, or quantity of n plus 1 to the third power, over 5 raised to the quantity of n plus 1. A lot of parentheses here. I think I used it just to kind of clarify what goes where. And then we're going to take the limit of this new expression in our numerator and divide it. When I finish writing it out, you do the same. Divided by our old expression, a sub n. And, oh, these should not be parentheses. What am I drawing here? Okay, take your eraser or whiteout tape, whatever you need. These should be absolute values. I knew to put something there. I was just such in a habit of writing with the numerous parentheses that we have here. I was making a parentheses everywhere. I don't need too much. I don't even need this one. See, I'm adding an extra parentheses. There's not even one there. That's just me being silly today. So if you plug in all values of 1 or 2 or 3, okay, it's quite possible that you could end up with a negative answer or a positive answer, okay? However, that negative 1 to the n plus 1 power over negative 1 to the nth power is going to simplify. Okay, so let's take a look at how it simplifies, and then we can see what we can do from there. So let's take, just use the absolute value for right now. So if we keep this, and you see how we have this expression. So same base, you can subtract the exponents, okay? And, okay, so that alone is going to give you negative 1. And if we take the absolute value of that, it's just going to be 1. So even if you like left all of this here, I'm trying to write it out correctly. So many parentheses I wrote. Okay, you at this point no longer need the absolute value, because for every value of n, it's going to be positive. So this brings this to like a positive 1. You can write it like that, but it's not necessary because the absolute value of this is 1 and the absolute value of this is still going to be positive. So now we're just working with these two fractions. It's a complex fraction. Okay, it's just made up with two fractions inside, one in the numerator, one in the denominator. So if we do keep, change, flip, which is going to help us a lot, we can then find the limit of this expression. Okay, so obviously we can see we don't need the 1 there. Same base, we can subtract the exponents. So we end up with 5 to the negative first power, so that is going to be 1/5. Let's see if we can simplify this. Okay, so if we take a look at this, it's very interesting. We can rewrite this is supposed to be a multiplication sign, as n plus 1 over n to the third power. Okay, so now we know about the constant. We can always pull that out in front of the limit. And if we multiply this out, okay, this the numerator, n plus 1 times n plus 1 times n plus 1. Okay, you're going to get something that is n cubed. And same thing, the denominator, you're going to get like n cubed. So you can use like n behavior model if you want. You can try multiplying this out and do like L'Hopital's rule to find its limit. But if you take a look at this, to remind you, you can see the exponents are equal. You can divide the leading coefficients. This is going to be 1. And 1 times 1/5 is 1/5. Well, since 1/5 is less than 1, this too converges. Okay, so in future problems, if you work it out and you find that it's greater than 1, just remember it means that it diverges. And if you're unlucky enough that it equals 1, you can write it's inconclusive by the ratio test, but try to use a different test, see if it could work out a different way. All right, let me know if you have any questions. Good luck.